Are you ready for a fact that sounds like a system glitch? There is a building material that, in a fire test, can withstand temperatures of around 900 degrees Celsius for an hour, while the interior side of the wall remains almost cold. A material that, as it hardens, does not release carbon dioxide, but gradually binds it. A material that naturally regulates humidity in a house so effectively that mold simply cannot survive in it. And this material is not a futuristic laboratory invention, it's hemp. If you just smiled skeptically, hold on. The most interesting part is yet to come. The construction industry is one of the most conservative and most polluting sectors in the world. Cement, steel, synthetic insulation, all of this has become the norm. We build fast, in large quantities, and cheaply, but we rarely ask at what cost. About 8% of global CO2 emissions come from cement production alone. Houses burn. Synthetic insulation releases toxic gases in fires. Mold in walls is a chronic problem in humid regions, and we call this standard. Now imagine an alternative. A material made of 3 components: the woody core of the hemp stalk, lime, and water. It is non-load-bearing. It needs a frame. But as an infill insulation layer, it behaves differently from anything we are used to. It breathes. It lets vapor pass through without trapping moisture. It creates an alkaline environment inside the wall with a high pH, where mold cannot feel comfortable. It is lightweight, significantly lighter than traditional concrete. And yes, it shows remarkable results in fire tests, because the combination of lime and plant filler behaves differently from wood or plastic. But let's dig deeper. Why has this barely been discussed in the US for decades? Until the mid-20th century, industrial hemp was a common agricultural crop. It was grown for ropes, fabrics, and paper. However, in 1937, the Marijuana Tax Act was passed, using the term marijuana, a word associated with drugs, instead of the familiar hemp. Later, in 1970, the entire species Cannabis sativa was placed on the list of strictly controlled substances without clear distinction between psychoactive strains and industrial hemp with minimal THC content. Historians still debate the reasons. Some cite racial politics and moral panic. Others mention industry interests. But the fact remains, industrial hemp disappeared from the legal field for nearly half a century. And it's not just a ban on cultivation. It's the absence of building codes, standards, and insurance mechanisms. If a material is not in the regulations, you won't get a permit. You won't secure a mortgage. You won't convince a bank. It may exist physically, but legally it is as if it doesn't exist. The construction system is such that without regulatory support, a material cannot become mainstream. It wasn't until the 2018 Farm Bill that industrial hemp was removed from the list of banned substances, returning it to the category of agricultural crops. From that moment, pilot projects, experimental homes, and the inclusion of hempcrete in applications of international building codes as a non-load-bearing insulation material began. Slowly, cautiously. But the movement started. It's important not to romanticize. Hempcrete is not a miracle or a universal replacement for everything. It cannot bear the load of a multi-story building without a frame. It is more expensive than a traditional frame with synthetic insulation. It requires proper protection from direct contact with soil and thoughtful design. This is not magic. This is engineering. But here's what makes the story truly interesting. We live in an era when climate risks are rising, fires are becoming more intense, and energy efficiency requirements are tightening. And suddenly, it turns out that the solution may not lie in more complex chemistry, but in returning to a material that combines ancient lime technology with a fast-growing plant. Scientists cautiously speak in publications about the potentially negative carbon balance of such walls. Engineers note their vapor permeability. Builders who have worked with them speak of a different spatial experience, more stable humidity and temperature. And here's the key question I ask, not as an activist, but as someone looking at numbers and trends. If we have a material that potentially reduces the carbon footprint, shows high fire resistance, and creates a healthy microclimate, why is it still niche? The answer is probably not in conspiracy theories. The answer lies in system inertia, in the fact that trillion-dollar industries do not pivot in a single season, in the fact that codes take years to rewrite, in the fact that banks and insurance companies prefer predictability. But the story of hempcrete is the story of a forgotten technology returning at a moment when the world starts looking for alternative solutions, not because it's trendy, but because the pressure of reality has become too strong. And now, after learning about the incredible fire resistance and carbon-absorbing ability of hempcrete, it's time to look at what this material does in real life and why it amazes engineers and builders. Imagine a reservation in Minnesota where old houses were literally dying from moisture and mold. Every year, residents paid thousands of dollars for heating because the old walls couldn't retain warmth. Then came a project using hempcrete. Within a few days, builders filled the frames with the new material, and within a month, families noticed the difference. The walls breathe, indoor humidity stabilized, the air was dry, and heat was retained better than in any house they had ever lived in before. Stayed at an optimal level for human health, 40 to 60%. Even more astonishing, in both laboratory and practical settings, hempcrete behaves almost like a living material. Scientists observed that when exposed to prolonged moisture, the hemp core in the wall gradually swells and distributes moisture across the entire cross-section of the wall, preventing mold or rot from forming. And when the walls dry, the material does not crack or shrink, it self-regulates. Engineers witnessing this effect for the first time reportedly could hardly believe their eyes. Such self-healing and shape-retaining properties are extremely rare in building materials. Another striking fact: hempcrete absorbs sound almost like an acoustic panel. In houses built with this material, interior noise levels drop by tens of %. Imagine living on a busy street, but inside your home it is quiet. Not thanks to synthetic panels or expensive acoustic materials, but because of an ordinary plant, ground, and mixed with lime. The architectural possibilities are impressive as well. Hempcrete is lightweight yet malleable. In Europe, it has been used to restore historical buildings, where using traditional cement would have destroyed the structure. It allows the creation of domes, arches, and complex shapes that retain strength for centuries. In the US, pilot projects have built entire settlements from hempcrete blocks, not just houses, but full-scale solutions with excellent thermal insulation, soundproofing, and durability. Scientists also note another effect. The material constantly changes its chemical composition by absorbing carbon dioxide from the atmosphere and converting it into calcium carbonate, literally turning it into stone. This process continues for decades. Walls built today become stronger over time. No one has seen this happen with conventional concrete. It simply ages and loses strength. As if that weren't enough, hempcrete has yet another superpower. It protects buildings from thermal shock. In real-world experiments, the material was subjected to sudden temperature changes and high humidity simultaneously, and it neither cracked nor deformed nor lost functionality. Engineers were genuinely astonished. Similar tests on concrete or wooden structures almost always resulted in damage. Aesthetically, hempcrete also impresses with its versatility in finishing. Walls can be coated with natural lime plaster and maintain a living appearance for centuries. Artisans note that frescoes and artwork on these walls remain vibrant for decades because the material maintains a stable microclimate, preventing shrinkage and cracks. In historical European buildings using hemp mixtures, artwork applied hundreds of years ago still looks almost new. Another remarkable fact: hempcrete is so resistant to microorganisms that some researchers call it a living wall. Microbes, mold, and insects simply cannot find conditions to thrive. Yet the material remains completely safe for humans. No toxicity, no chemical additives. Modern projects demonstrate that hempcrete can be used not only for residential homes, but also for schools, offices, and gyms. In experimental conditions, walls have withstood both mechanical loads and extreme climate conditions. People living in such buildings report that the air inside feels lighter, breathing is easier, and the walls seem to work with the house, maintaining an optimal microclimate. When you think about it, this is almost an engineering miracle, a natural material combining strength, durability, fire resistance, soundproofing, moisture regulation, protection from microorganisms, and carbon sequestration. And all of this comes from a plant that can be grown in a few months without pesticides, with minimal water and fertilizer.